Gentlemen, this is Ms. Pashauer. I know you're super excited. We are starting our first lesson of Unit 10. Okay, Unit 10 is going to be a fairly quick one, only about 2 weeks, but we're going to kind of dive into two interesting type of functions. We're going to do radicals and cubic functions, okay? The cubic functions are going to come in, one of the last few days, real basic stuff. Radicals are things where we are going to do a little bit more math. Talking about simplifying radicals. How do you simplify the square root of 50? From up until this point, we've said, oh, well, I'll just punch that in my calculator. Square root of 50, I put it in, I get an answer. But what we're going to talk about now is how we can simplify that, taking things out of the radical and leave it in a way that isn't necessarily a big, ugly decimal. But maybe we could take this into 25 times 2. And isn't 25 a perfect square? We could take that out. So this would be the same as 5 times the square root of 2. We're not going to do this for a few lessons, but just giving you a little brief introduction to where we're going. We're going to do simply some simplifying of square root. We call them radical functions. And then we're also going to do some graphing. Okay, our cubic function looks like this kind of fun S shape, and we'll talk about why that happens later on. We're also going to do some translations, and if you remember how it works with quadratics, if we add things on the end, I don't know what happened there, that's supposed to be a 2. We add things on the end, how it might affect our graph. And then, that should be very similar to what we learned with parabolas and quadratic functions. So a lot of these patterns continue, which is really cool, because if you understand the idea, then you don't have to memorize things. How will we move it left and right? Well, that'll be a fun discussion that we'll have in a little while, but hopefully you might see some patterns with what we've done before. So, yeah, we're just going to kind of jump into our second to last unit. And so why don't we go ahead and get started? Give yourself a title. This is Unit 10, Radical Functions and Cubic Functions, okay? We're going to start with the idea of where is this found in the real world? Okay, this is talking about astronauts at NASA. And they are training and they're using something called the Vomit Comet. I mean, something's cool when it's called the Vomit Comet. So I don't think I'm going to get into this now because this is like how I would really I'd like to introduce this to you guys in class on Monday and kind of talk about this little YouTube video that we're going to watch and use this as a fun discussion point to start the unit. So I'm not going to talk about this now, but it is important to note it. One of the questions that's coming up is going to talk about being weightless and all that kind of stuff. So this function, it says y equals 8 times the square root of x, is the speed in feet per second of an object in free fall. Okay, after it happens to fall x feet. Okay, so the x here is how many feet that it has fallen, or the distance of falling. Okay, so we'll get to that. Get you a little excited about class on Monday, but why don't we just kind of get into the basics of the ideas. So Unit 10, Lesson 1, the basic ideas of square root functions. Okay, what do we need to know about square root functions? Well, like I said earlier, this one here is talking about free fall. It's not really something we've done before. It is different from those we've learned so far in algebra. It's called a square root function, or sometimes called a radical function. Okay, those are synonyms. And it contains a variable under the square root symbol. Okay, if you have y equals the cube root of x, that's a totally different function. Okay, this little 3 here changes it to do something totally different. So we're only talking about square roots here, guys. Okay, square roots. Just to remind you, the square root of 25 is 5 because 5 times 5 makes 25. That's the square root 2 times, right? A number times itself twice. That makes 25. That's how you take the square root. Okay, so here are some examples of square root functions, what they look like. Okay, and again, it is a function whose rule contains a variable under the square root symbol. Here are some examples of what they look like. Here are some examples of what they don't look like. Okay, what's going on with this third one? That one's kind of fun. I see a square root, but it is purposeful that that square root symbol only goes on top of the 3. Okay, what kind of function might that be? It looks to me like y equals, that would be the same as writing, the square root of 3 times x. Okay, isn't that just a number? The square root of 3 is just a number, like 1 point something. So what do you guys think that kind of function would be? Hopefully you said linear. Okay, that last one is linear. This one is quadratic, we just did. This one's called a rational function. We're not going to do those this year in Algebra 1, but I got to leave something fun for you guys to do in Algebra 2. So the first idea we're going to talk about is just evaluating. Okay, we've been doing evaluating since the beginning of the year, just plugging numbers in and seeing what we get. Okay, so find the speed of an object after it has fallen 4 feet. Y equals 8 times the square root of x, where x is the number of feet. Well, what do we got to do here, guys? We got to plug this in. So instead of writing x, we're going to write 4. Y equals 8 times the square root of 4. Remember, when I write something like this, what's happening in the middle there? It's a times, it's a multiplication. So, my calculator, I'm just going to find the square root of 4. Oh, guys, we don't need a calculator for that. I'm so sorry. What is the square root of 4? That's a perfect square. Okay, the square root of 4 is 2. Again, so sorry. I'm trying to get a handle on using the iPad here. Square root of 4 equals 2. So therefore, my evaluating here is pretty simple. 8 times 2 is 16. Okay, what does that mean? We should give it some units if it's a story problem. Find the speed of an object in free fall. Okay, free fall means it's just falling by its own force of gravity. Nothing else is affecting it. So 16 is what? 16 is the, I think that's in the previous slide. 16 is the feet per second, right? Feet per second. Okay, so it would be 16 feet per second. Why don't you guys try B? Okay, I'll kind of work through that silently while you work through it, and we'll hopefully meet at the end and see if you have the same answer. Okay, so give this one a try. Sorry. If you are finished, I am finished. If you're not, go ahead and press pause and catch up, no problem. Hopefully you have the same answer as me. I have 56.57 feet per second. Don't forget your unit. And in general, round to the nearest hundredth is fine. Okay, round to the nearest hundredth. How did I find the square root of 15? Simply plugged it in my calculator, okay? I don't expect you guys to do that by memory. Okay, let's move on. Finding the domain. Okay, one thing that's really, really important when we talk about square roots to remember is that the square root of a negative number is not a real number. I can't take the square root of negative 10. I just can't do it. I can't take the square root of negative 1. I can't take the square root of negative 47, whatever it is. I can't take the square root of a negative number. So if I'm looking at a square root function or a radical function, every single problem that you have to think about whatever is underneath here. All of this, okay, it's important to know that that piece, that expression, can't be negative. It just can't be. Otherwise, those are like no solutions. How do I write b negative, maybe in a more mathematical sense? Well, the number has to be greater than or equal to 0. Okay, and that's what you're going to do when it says find the domain. Remember, the domain is the possible x values. What could x be? If x can't be negative, the question they're asking you is, find the things that x could be. So you're really only concerned with this part that I've highlighted in orange. You're only concerned with that. The -3, that, you're not worried about that. What this problem is saying is the x plus 4 has to be greater than or equal to 0. So just write a little inequality statement. We remember inequalities, right? So solve that. X plus 4 has to be greater than or equal to 0. Subtract 4 on both sides. So what does x have to be, or what are the kind of constraints on your x values? X has to be greater than or equal to -4. And that'll confuse some people because they'll say, but I thought you said that the thing has to be positive. Okay, well, yeah, but whatever you're doing with x, you're going to add 4 to it. So let's pretend that x is equal to -3. It's a negative number. Isn't that a problem? Well, it depends on what you're going to do with x first. Okay, if my square root portion is x, gosh darn it, so sorry, x plus 4, then whatever x is, I'm pretending it's negative 3. If I do the square root of negative 3 plus 4, is that something that I can do? Is that okay? Is that like, smiley face or sad face? What's going on there? Well, the thing is, PEMDAS tells me that I got to do this part first. I got to do my adding or subtracting first. So really, this is just the square root of 1, because negative 3 plus 4 will, in the end, give you a positive number. Okay, so that's the kind of thing you're looking for here. Again, I think I'm going to have you guys try the second example because it keeps you awake, keeps you doing some math. I'll set it up for you if you'd like. But the idea is that, again, find the domain. Okay, that's what the question is asking you. Find the domain. Find the domain of each function. What could x be? In this case, this piece that's in the inside, 3 times x minus 2, has to be greater than or equal to 0. Okay, go ahead and solve that just like you solve any equation or inequality. I'll work it out here silently, and then we'll meet together at the end. All right, folks, I'm all set. If you're not, that's okay. Take your time, press pause. That's what's great about the video. And come back to me. If you are ready, I have x has to be greater than or equal to 2. That means the number 1, even though the number 1 is positive, it cannot work. It cannot be part of the domain. Why? Because 3 times 1 minus 2, we got to do that part first, right? 3 times negative 1 is negative 3. That's still a negative number. So in the end, you're putting a negative number underneath a square root symbol, which you cannot do. Okay, so the domain of this function, x has to be greater than or equal to positive 2. If it's less than or equal, if it's less than 2, then you're going to get, something that's kind of illegal. Okay, you can't take the square root of a negative number. Okay, let's keep moving on. Next, we're going to do some graphing. Okay, how would I graph this? If it's not a translation of the parent function, we're going to graph in a lot of the same ways that we've always graphed. We're going to pick x values. It's first important to find the domain because you don't want to choose x values that can't be. So let's find the domain real quick first. The square root of 2x, that's the part we're concerned about. I'm not going to write the square root symbol. I'm just going to say 2x has to be greater than or equal to 0. 2x is underneath the symbol. So 2x has got to be greater than or equal to 0. Divide by 2. X has got to be greater than or equal to the number 0. X has to be positive numbers. I'm not going to choose anything negative. I'm going to choose maybe 0. It's important to know right where that is. And I'm going to give you guys some values that work well, because otherwise you'll get some decimals and fractions. Let's pick 0, 2, 8, 18, and 32. Evaluate. How are you going to do this? You're going to do the square root of 2 times 0 and then add 3. The square root of 2 times 0, well, that's going to be 0 plus 3 is positive 3. Okay, why don't you guys go through and fill these out, and then we'll plot the points, and then we will make sure that we have a nice square root function. You kind of see what they look like. Okay, so press pause and come back to me when you're ready. Since you're back, I'm hoping that you got these points here. If you put in 0, you get 3. If you put in 2, you get 5. If you put in 8, you get 7. If you put in 18, you get 9. And if you put in 32, you're going to get 11. Okay, what does this look like when you graph it? 0. What am I counting by? This is interesting. This is 8, so this has got to be counting by 2. So 0 is 3. All right, 2. Here's 2. That's going to be 5. 8. X is 8. I get 7. When x is 18, here I get 9. And when x is, 32 is way over here, I get 11, which is right about there. Okay, we should get this kind of figure here. It's possible that that one's maybe in the wrong spot. This one looks a little weird here. But either way, we should mostly have the same points. It's possible I made a mistake there. 2 is 5, 2, 4, 5. Yep, that looks good. But square root functions look more or less like what we got here. Alrighty, that's how you graph if you don't have something that looks like the parent function. If you do have something that looks like the parent function, you can follow a lot of the same rules we learned last unit, which is super, super cool. Okay, we have these translations. Let's start here. How do I move my square root function up or down? Well, very similar to last unit, you simply add something to the end of it. Something that is not in the square root symbol. Okay, you're going to kind of stick it at the end. It's like the C value of the parabola. Okay, notice the purple one is up here at y-intercept of 4. Makes sense, you got a plus 4. The green one has a y-intercept of 2. And so on. The blue one has a y-intercept of 0 because you haven't added anything at the end. The red one has a y-intercept of -1 because you subtracted something at the end. Same as last unit. It should make sense. How do you think we move it left and right? Okay, when we did parabolas, if we had y equals x squared, how did we move that left or right? We added something, we added something inside the parentheses, x plus 2 squared. So this is inside to move it left or right. Any guesses on how I would move my square root function, left or right? This was on the outside. I'd move it left or right by putting it in the inside of the square root. Okay, this is super cool because they all connect. The purple one now is moved. If I add 4, remember how it kind of goes in the opposite direction? My x-intercept, I've moved it to the left 4 spaces. Okay, the green one, again, somehow I lost this 2 here. This is a plus 2, so I'm going to move it over here to left 2 spaces because of that there. Okay, so if you have the parent function, goodness gracious, very sorry. If you have the parent function, it's very similar to what we did last unit. Okay, you move things up or down by sticking something kind of on the end of your function. You move something left or right by kind of putting it inside the symbol. Okay, so I know I kind of maybe started this slide quickly, so maybe you didn't have a chance to write things down. This parent function, again, I lost a little bit of some of the visuals here. This should be the square root of x. Okay, so that's what the square root of x looks like as its parent function. And then this is how you move it left or right. If you want to kind of sketch this one here, it's in the inside, so that means I'm going to move it left or right. I'm not sure which one. If it's -4, it's the opposite of what you might think. So it's going to be that kind of shape like that. Okay. Any guesses? I know it's not here, but any guesses of how we'd flip this to the other side? Kind of flip them horizontally. Well, hopefully, we're thinking about what we did last unit. Wouldn't that be y equals -1 times the square root of x? Okay, wouldn't that flip it the opposite direction? There's a lot of really cool connections. Feel free to go back into the video and write things down if you need to write things down again. Have yourself a fabulous weekend. We will start on Monday with some of this classwork in class. Okay? Take care. I will see you on Monday.